Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling through the quiet legacy of NASA. From its humble beginnings to its far-reaching missions across the solar system and beyond, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the cosmos. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, and let's begin. Fact 1. The birth of an agency for the stars. Long before rockets traced silver arcs into the sky, the idea of NASA began as a quiet hope, a belief that humanity could look upward and learn to wander beyond the familiar blue. In 1958, that hope became real, shaped into an agency devoted to exploration, discovery, and gentle curiosity. It was born not with fanfare, but with intention, to understand the cosmos and to share that understanding with the world. NASA's earliest days were filled with small rooms, careful planning, and quiet determination. Scientists gathered around chalkboards and simple desks, sketching possibilities that stretched far beyond the horizon. Their work, delicate and deliberate, became the foundation of every mission yet to come. And from that humble beginning, a new chapter of human wonder softly began to unfold. Fact 2. A nation dreams of space. As NASA took shape, the world was already looking to the sky with growing fascination. Telescopes had revealed a universe of impossible distances, and early rockets hinted at paths that might one day lift humans beyond Earth altogether. The United States, inspired by both competition and curiosity, dreamed of a future where the stars felt just a little closer. In classrooms and living rooms, children watched grainy broadcasts of early test flights, imagining themselves drifting weightless among distant constellations. Even adults found comfort in the idea that exploration could bring unity, that in the quiet of space, humanity might discover a sense of shared purpose. This dream, gentle yet powerful, became the heartbeat of NASA's first missions, guiding them toward the unknown with steady calm. Fact 3. NASA's first quiet offices. NASA's earliest offices were modest places, converted military buildings, temporary labs, and simple hallways where the future of spaceflight was planned over soft conversations and long, patient nights. There were no glowing control panels or roaring engines yet, only pencil marks, typed memos, and the soft scratch of blueprints being rolled open. Engineers worked side by side with mathematicians, blending equations with imagination. They mapped the delicate balance between gravity and thrust, studying how a spacecraft might rise gently into orbit without tearing itself apart. Every calculation carried both risk and hope, and every small success felt like a step closer to the stars. In these quiet rooms, NASA learned to dream in detail and to build those dreams with careful hands. Fact 4. The spirit of exploration takes root. In those earliest years, NASA's spirit wasn't loud or triumphant. It was gentle, patient, and quietly determined. The agency grew from a simple belief that learning about the universe could deepen our understanding of ourselves. Engineers, scientists, and dreamers gathered not for glory, but for the quiet joy of discovery. They studied the soft curves of planetary orbits, the fragile balance of spacecraft design, and the ways a rocket might whisper its way past Earth's atmosphere. Every idea was a seed, planted with care and nourished by curiosity. And as the months passed, that spirit of exploration slowly took root, preparing to lift humanity into a new era of celestial wonder. Fact 5. The early engineers of wonder. The first engineers who joined NASA came from many paths, some from aviation, some from physics, some from mathematics, but all carried a shared sense of awe. They weren't just building machines. They were crafting vessels meant to glide through silence itself. In small, sunlit offices, they calculated trajectories by hand, letting pencils trace arcs that would one day become real journeys above the Earth. They tested materials, fuels, and designs, each experiment a whisper of future missions. Their work required not only intelligence, but patience, the kind of patience that welcomes mistakes as gentle teachers. These early engineers became the quiet architects of exploration, guiding NASA's first steps with steady, thoughtful care. Fact 6. The first rockets, whispered to life. Before astronauts floated in orbit or spacecraft drifted toward distant planets, NASA watched its first rockets flicker awake on the launch pads. They were small compared to the giants that would come later, but each one carried the weight of countless hopes. When their engines ignited, it wasn't the roar that mattered. It was the promise rising inside that flame. These early rockets climbed only a short distance into the sky, but they offered precious lessons. How machines behaved under stress, how guidance systems found their balance, how heat and pressure shaped every moment of flight. Engineers stood far below, listening to the data, learning the quiet language of launch. Each rocket became a stepping stone, lifting NASA gently toward the stars waiting above. Fact 7. The space race begins. As NASA's early rockets stretched their flames toward the sky, the world beyond America was also looking upward. The Soviet Union had already sent Sputnik drifting through the quiet dark, and its steady radio pulse echoed around the planet like a soft reminder that space was no longer empty of human touch. This moment stirred a gentle urgency within NASA, not a rush born of fear, but a renewed belief in what might be possible. Engineers and scientists felt the weight of a new era settling around them, an era defined not by conflict, but by the shared human desire to explore. And so the space race began, not with a sprint, but with a dream rising slowly into the night. Fact 8. Crafting a path beyond Earth. To reach space, NASA first had to imagine the path that would take humanity there. The problem wasn't only technological, it was poetic. How do you leave your home world behind without forgetting where you came from? How do you build a vessel that survives the fire of launch, the stillness of orbit, and the warmth of return? Teams worked quietly through evenings, sketching gentle arcs of orbital mechanics, studying how a tiny capsule could fall safely back through the atmosphere's glowing embrace. They tested parachutes, heat shields, and tiny guidance systems, each one a promise of safety for future travelers. Piece by piece, they crafted a path, a delicate ladder leading upward, rung by careful rung, into the soft dark above. Fact 9. NASA's first scientific missions. Before astronauts took flight, NASA sent its curiosity upward on unmanned missions, allowing instruments to breathe in the thin air of space long before human lungs ever would. These early missions studied radiation, atmospheric composition, and the quiet behaviors of Earth's magnetic field. The satellites were small, almost modest, but they carried the gentlest of questions. What is space made of? How does our planet glow from above? What secrets float in the silence just beyond the sky? As data drifted back to Earth in soft streams of numbers, scientists gathered around printouts with the same reverence one might give to a new constellation. These early findings shaped the missions that followed, each discovery a lantern lighting the road ahead. Fact 10. A new era of possibility. With each early mission, NASA felt a quiet shift, as if the sky itself were opening just a little wider. What once seemed impossible now felt like a distant but reachable shoreline. Engineers and scientists began to sense that humanity's relationship with space was changing, moving from imagination into gentle reality. The agency expanded slowly, welcoming new minds, new ideas, and new perspectives. Laboratories hummed softly through the night as researchers measured temperatures, pressures, and cosmic rays. The numbers were small pieces of a large, unfolding dream. Every successful test, every return signal, every bright arc of a rocket lifting into the dark was a reminder that a new era had quietly begun. One where exploration was no longer a wish, but a path. Fact 11. The Mercury 7-step, forward. NASA's first astronauts were not chosen for glory, strength, or bravado. They were chosen for their calm, steady courage, the kind that settles quietly in the heart. The Mercury 7, as they came to be known, stepped forward with a mixture of humility and wonder, knowing they might become the first humans to slip the bonds of Earth. Each astronaut trained for long hours, learning how it felt to float in aircraft that mimicked weightlessness. They practiced emergency procedures, studied orbital mechanics, and grew comfortable with the gentle hum of the capsule they would one day trust with their lives. And though the world saw them as heroes, they saw themselves simply as caretakers of a new frontier, the first sparks of human presence in the quiet of space. Fact 12. Learning to orbit Earth. Before a person could orbit Earth, NASA needed to understand the delicate dance required to stay aloft without drifting away. Orbiting isn't about climbing higher. It's about moving fast enough that you continually fall around the planet instead of down toward it. Engineers studied this elegant balance with fascination, mapping how a capsule would glide along Earth's curve, always falling, but never landing. Simulators gently rolled and spun, teaching astronauts what it might feel like to ride along this invisible path. When the first Mercury missions reached orbit, the Earth below appeared calm and glowing, a soft swirl of clouds and oceans. In that moment, humanity learned not only how to orbit, but how to see our world with a new, tender perspective. Fact 13. The challenge of weightlessness. When NASA first studied weightlessness, it felt like exploring a world where familiar rules dissolved into quiet mystery. On Earth, gravity anchors every movement, but in orbit, that anchor gently disappears. Astronauts floated in training aircraft, rising and drifting as though suspended in a slow, silent dream. Scientists wanted to understand how the human body would respond to this new environment, how hearts would pump, how muscles would move, how minds would adjust to a place where up and down no longer existed. The sensations were strange, but also strangely peaceful, like drifting on a calm sea without waves. As NASA learned the rhythms of weightlessness, the door opened to longer missions, where floating would become not a novelty, but a way of life. Fact 14. The quiet courage of early astronauts. The astronauts who trained for NASA's first flights carried a kind of courage that was gentle rather than loud. They faced unknowns with steady breaths, understanding that each mission would teach humanity something new about space and about ourselves. Their days were filled with practice, entering capsules, studying controls, memorizing checklists, and solving problems in simulators that mimicked emergencies they hoped would never come. Yet through it all, they remained calm, trusting in the engineers who crafted each bolt and wire with care. When launch day approached, they stepped forward not as adventurers seeking adrenaline, but as quiet pioneers carrying the hopes of millions. Their courage became the calm heartbeat of NASA's early years. Fact 15. The Gemini missions take shape. After the Mercury program proved that humans could survive in space, NASA prepared for the next step, Gemini, a series of missions designed to teach astronauts how to live and work beyond Earth for longer periods. If Mercury was about touching space, Gemini was about learning to navigate it gracefully. Engineers built a new two-person capsule, giving astronauts the chance to practice tasks they'd need for future journeys to the moon, docking with other spacecraft, performing spacewalks, and mastering extended stays in orbit. These missions were like rehearsals, quiet and methodical, each one adding a new layer of understanding. As Gemini took shape, it became clear that NASA was gently assembling the skills needed for the most ambitious dream of all, reaching the lunar surface. Fact 16. Practicing spacewalks in silence. Before astronauts could ever step outside a spacecraft, NASA needed to understand how a human could move in the vast, silent ocean of space. The challenge wasn't just technical, it was deeply human. How does a person stay steady with no weight, no wind, and no ground to push against? To prepare, astronauts trained underwater, where motions felt slow and buoyant, mimicking space's gentle resistance. Divers guided them through careful movements, teaching them how to use handrails, tethers, and the quiet strength of their legs and arms. Every motion had to be deliberate, like a slow dance performed in a dream. These early underwater rehearsals became the soft foundation of future spacewalks, showing astronauts how to work gracefully in the silence above Earth. Fact 17. Rendezvous above the Earth. One of Gemini's most important lessons was learning how two spacecraft could meet in orbit, a skill essential for journeys to the moon. In the vacuum above Earth, this wasn't like planes meeting in the sky. There were no winds, no sounds, and no simple steering. Everything depended on gentle bursts of thrusters and a deep understanding of orbital motion. Astronauts practiced approaching another craft slowly, inch by inch, until the two vehicles drifted together in perfect alignment. It was a delicate ballet, choreographed by physics and performed with calm precision. When the first successful rendezvous occurred, it confirmed that NASA could build the intricate steps needed for lunar travel. In the stillness of orbit, two ships found each other, and humanity took another quiet leap forward. Fact 18. Testing the limits of human endurance. To understand how long humans could live and work in space, Gemini missions stretched their durations gently upward, from hours to days to nearly 2 weeks. Astronauts floated inside their capsules like travelers in a small drifting cabin, learning how their bodies and minds adapted to life without gravity. They slept in soft restraints, ate simple meals, and performed experiments as the Earth turned slowly beneath them. The days were repetitive, but in that repetition came insight, the realization that humans could endure space not just physically, but emotionally. finding calm in the rhythm of orbit. These missions showed that long journeys were possible, preparing NASA for the quiet, determined steps that would soon lead toward the moon. Fact 19. Preparing for the moon. As the Gemini missions taught NASA how to maneuver, dock, and endure long stretches in space, a quiet realization settled over the agency. The moon was no longer a distant dream. It was becoming a destination. To prepare, engineers studied every detail of lunar travel: how to guide a spacecraft across hundreds of thousands of miles, how to land softly on unfamiliar soil, and how to bring astronauts home through the glow of Earth's atmosphere. They examined the moon's surface through telescopes and early probes, mapping craters and plains like cartographers of a world no one had ever touched. Training shifted toward the long voyage ahead, blending science with imagination. With each new insight, the path to the moon grew clearer, like a trail appearing under gentle light. Fact 20. Lessons that lit the way forward. Every Gemini mission ended with lessons, some small and subtle, others vast and transformative. Engineers studied telemetry the way poets study lines, carefully, patiently, searching for meaning in the details. They learned how spacecraft responded to heat, cold, and the quiet pull of microgravity. They learned how astronauts managed fatigue, how onboard systems endured long missions, and how delicate spacecraft could be coaxed to behave in the stillness of orbit. These lessons didn't just prepare NASA for the moon. They shaped how the agency approached every mission afterward. The knowledge gained became gentle lanterns, illuminating the path that stretched from Earth to the lunar horizon. From each success and each challenge, NASA gathered understanding, and with it, confidence for the journey ahead. Fact 21. The dream of lunar footsteps. Long before Apollo rockets thundered skyward, the idea of humans walking on the moon lived quietly in the minds of many. NASA transformed this distant dream into a plan, one grounded in mathematics, engineering, and the steady belief that humanity could reach a new world. The moon was not just a destination, it was a symbol of possibility. Its pale light had watched over Earth for billions of years, and now, for the first time, humans prepared to return the gaze. Artists sketched what the surface might look like up close. Scientists imagined the feel of lunar dust beneath a boot. Astronauts trained for steps they had yet to take. And with Apollo emerging on the horizon, the dream of lunar footsteps began to glow more brightly than ever before. Fact 22. Building the Saturn V. To reach the moon, NASA needed a rocket unlike anything the world had ever seen. A gentle giant capable of lifting dreams into deep space. The Saturn V was that giant. Standing taller than a 36-story building, it rose from the Earth with quiet majesty, even before its engines ever fired. Engineers designed it layer by layer, crafting a tower of fuel, metal, and delicate circuitry. Despite its immense power, the rocket had an almost poetic precision. Every bolt, every wire, every tank had to work in perfect harmony, forming a machine that would guide astronauts safely across the void. The Saturn V became more than a rocket. It became a symbol of human aspiration, a ladder stretching into the night sky. Fact 23. The slow rise of a giant rocket. Before each launch, the Saturn V was carried slowly to the pad on a massive crawler, moving at a pace gentle enough to feel like a ritual. Inch by inch, the rocket glided over the ground, accompanied by quiet footsteps and the hum of machinery. This slow procession gave everyone a moment to appreciate the miracle they were building. Technicians walked alongside it, checking connections, listening to soft mechanical murmurs, ensuring that nothing was out of place. The air around the rocket felt heavy with anticipation, yet peaceful, as though time itself slowed to watch. When the Saturn V finally stood upright on the launch pad, it appeared almost serene, resting patiently as it awaited the fire that would lift it above the clouds. Fact 24. Apollo's unseen workforce. While astronauts stood in the spotlight, thousands of people worked quietly behind the scenes to make Apollo possible. Engineers, seamstresses, programmers, welders, mathematicians, and countless others contributed their steady hands and thoughtful minds. Many of them never witnessed a launch in person, yet their efforts traveled all the way to the moon. Programmers wrote code line by line on machines that hummed gently through the night. Technicians stitched spacesuits with the same care one might use when sewing a child's blanket. Analysts calculated trajectories with unwavering focus, ensuring every path was safe and true. This unseen workforce formed the foundation of Apollo, a calm, collective heartbeat guiding each mission forward into the quiet dark. Fact 25. Navigating the way to the moon. Reaching the moon required a kind of celestial navigation unlike anything attempted before. NASA's teams mapped the journey with incredible care, tracing routes through the quiet reaches of space where gravity from Earth and Moon softly intertwined. Trajectory planners studied how a spacecraft could drift along this invisible thread, using small bursts of thrust to guide its path like a sailor adjusting sails on a calm sea. Inside mission control, large projections displayed delicate curves showing where the spacecraft would glide hour by hour. Every adjustment had to be gentle, every calculation precise, for even the smallest error could shift the ship's arrival by miles. Through patience and an exquisite understanding of the sky, NASA learned to navigate the space between worlds with quiet grace. Fact 26. The first lunar orbits. Before humans could land on the moon, they first had to learn how to circle it. Early Apollo missions slipped into lunar orbit like travelers arriving at a silent, ancient harbor. As the spacecraft rounded the moon's far side, radio signals briefly faded, leaving astronauts wrapped in a moment of pure, cosmic solitude. From the windows, they watched the surface drift beneath them, a landscape untouched, filled with soft grays and long shadows cast by distant mountains. The craters appeared serene, like dimples in powdered dust. The moon offered no sound, no breeze, only stillness. These early orbits revealed the true nature of the lunar world, preparing NASA for the next gentle step, finding the perfect place to land. Fact 27. The Eagle prepares to land. When Apollo 11 separated into its two modules, the command module above and the lunar module below, a calm tension filled the air. The lunar module, called the Eagle, carried Neil Armstrong and Buzz Aldrin on their delicate descent toward the surface. Unlike a plane, it had no wings and no glide. It descended by controlled, whispering thrust, balancing itself on pillars of flame. Inside the module, alarms flickered softly, and the astronauts made quick but steady decisions, their voices calm despite the enormity of the moment. Outside, the lunar surface grew clearer, a quiet plain of dust, rocks, and unbroken history. As the Eagle gently lowered itself toward the sea of tranquility, humanity approached the threshold of its first footsteps on another world. Fact 28. The first footsteps on quiet dust. When Neil Armstrong stepped from the Eagle onto the moon's surface, the moment unfolded with a gentle stillness. There was no wind to carry sound, No rustle of air beneath his boots, only the soft press of his footprint into dust that had rested undisturbed for billions of years. The grains clung lightly to his suit, forming delicate patterns shaped by ancient sunlight and silence. As Buzz Aldrin joined him, the two astronauts moved slowly, learning the rhythm of lunar gravity. Each step was like a slow hop, graceful and unhurried. The surface felt firm beneath its powdery top layer, a quiet reminder that another world had welcomed human presence. In that serene landscape, humanity's first footsteps became a whisper across time, a tender promise of future exploration. Fact 29. Samples from an ancient world. One of Apollo's most peaceful tasks was the gathering of lunar samples. The astronauts moved with deliberate care, scooping stones and dust that held the moon's long, silent history. These rocks had never known rain, wind, or the passage of life. They were pure fragments of the early solar system, preserved in fragile stillness. Back on Earth, scientists studied them like treasured letters from a distant relative. Each mineral revealed something new: how the moon cooled, how its crust formed, how impacts shaped its surface. Some samples carried tiny glass beads, formed from ancient meteor strikes that melted and then froze the lunar soil. These simple, quiet rocks deepened our understanding of the universe's beginnings, reminding us that even dust can hold stories older than Earth's oceans. Fact 30. The legacy of the Apollo program. As the Apollo missions continued, each journey added new layers to NASA's growing legacy. Astronauts explored valleys, highlands, and craters, setting up instruments that listened gently to moonquakes and measured the moon's subtle movements. The program blended bravery with careful science, creating moments that still echo softly through history. Though Apollo ended after 6 successful landings, its influence remained woven into every future mission. Engineers carried forward the lessons learned: how to navigate space, how to manage long-distance communication, how to design systems that keep humans safe far from home. Apollo became a lantern for the decades to come, shining a steady light on what humanity can achieve through curiosity, patience, and a shared dream of exploration. Fact 31. Skylab, America's first home in space. After the moon landings, NASA turned its attention to something gentler: building a place where humans could live and work in orbit for weeks at a time. This became Skylab, a peaceful outpost drifting far above Earth's clouds. It wasn't large by today's standards, but inside its cylindrical walls, astronauts found room to sleep, eat, exercise, and study the world below. Skylab floated like a small sanctuary, offering long, quiet days for experiments in microgravity. Plants sprouted slowly in its calm interior. Materials behaved in new, delicate ways. Even human bodies revealed subtle changes under the soft pull of orbit. As Earth turned silently beneath them, astronauts experienced what it felt like to call space a temporary home, a gentle stepping stone toward the future. Fact 32. Life aboard an orbiting workshop. Living aboard Skylab meant adjusting to a world where every movement carried a softness. Without gravity's steady hand, astronauts drifted rather than walked, floating from place to place with a gentle push of fingertips. Simple acts, eating, sleeping, washing, became experiments in grace and patience. Meals traveled quietly in sealed packages. Sleep came in small bunks, where astronauts fastened themselves lightly to the walls, letting their bodies rest in weightless ease. The Earth outside the window changed hour by hour, oceans shifting from blue to silver, clouds stretching like soft brushstrokes across continents. Life aboard. Skylab revealed how serene long-term spaceflight could be, offering a first glimpse of the peaceful rhythms future space stations would one day embrace. Fact 33. The dawn of the Space Shuttle. When Skylab completed its journey, NASA prepared for a new era, one built on reusability and graceful return. The Space Shuttle emerged as a remarkable creation, part airplane, part spacecraft, designed to glide back to Earth like a quiet bird after soaring through the vacuum of space. Its wings promised something entirely new: missions that could carry large payloads, repair satellites, assemble future stations, and return safely to the ground time after time. Engineers shaped its tiles, engines, and cargo bay with delicate precision, forming a vessel that combined strength with elegance. The dawn of the Space Shuttle marked the beginning of a long, gentle chapter in NASA's story, one where humans could journey to orbit again and again, always returning home on a soft, drifting glide. Fact 34. A reusable ship takes shape. The Space Shuttle was unlike any spacecraft NASA had designed before. It wasn't meant for a single voyage, but for many gentle journeys, a ship that could rise through the fire of launch and return through the quiet of the atmosphere again and again. Engineers shaped it with wings for gliding, a large cargo bay for carrying experiments, and delicate thermal tiles to protect it during re-entry. The shuttle became a symbol of continuity, bridging Earth and space with a kind of graceful practicality. When it sat on the launch pad, it looked almost serene, pairing the strength of a rocket with the elegance of an aircraft. Each mission it flew would help expand our understanding of life in orbit. In its reusability, the shuttle whispered a simple promise: space was becoming a place we could visit often, not seldom. Fact 35. The shuttle's gentle glide to Earth. One of the shuttle's most peaceful moments came at the end of each mission, when it drifted back toward Earth on a long, silent glide. Unlike capsules that parachuted into the sea, the shuttle returned like a soaring bird, dipping through the sky on outstretched wings. There were no engines during descent, only soft control surfaces guiding it home. Astronauts watched the horizon brighten as layers of atmosphere wrapped gently around the craft. The runway below looked quiet and narrow, waiting patiently for the shuttle's wheels to touch down. When they finally did, the sound was soft, almost tender, marking the end of days or weeks spent floating above the world. That glide became one of the shuttle's trademarks, a reminder that even after traveling hundreds of miles above Earth, the journey back could feel peaceful and familiar. Fact 36. The Hubble's launch into darkness. One of the shuttle's most meaningful gifts to humanity was the deployment of the Hubble Space Telescope. Carried carefully in its cargo bay, Hubble was released into orbit, like a precious lantern destined to float above the world. Its golden panels unfolded slowly, catching sunlight as it drifted deeper into the quiet dark. Astronomers waited with anticipation, imagining the wonders it would reveal. Distant galaxies, glowing nebulae, and faint stars older than Earth itself. Though its first images would require later adjustments, the telescope's presence in orbit marked a profound moment. Humanity had placed its eyes beyond the blurring veil of our atmosphere. With Hubble's gentle launch, NASA opened a window that would change how we see the universe, a window glowing softly among the stars. Fact 37. The Hubble's first unclear vision. When Hubble sent back its first images, the world expected crystal-sharp stars and breathtaking galaxies. Instead, the pictures arrived a little blurred, edges softened like shapes seen through sleep-touched eyes. The telescope's main mirror had a tiny flaw, only microns wide, yet it gently distorted the light traveling across billions of miles. Scientists felt a quiet disappointment, but not defeat. They studied the issue patiently, tracing the distortion with delicate precision. The world waited, trusting that NASA would find a solution as steady and elegant as the telescope itself. In this brief moment of imperfection, Hubble reminded humanity that even great dreams sometimes arrive softly, needing a little more care to fully shine. Fact 38. A repair that saved the stars. To restore Hubble's vision, NASA planned one of the most delicate missions in spaceflight history. A team of astronauts boarded the shuttle, carrying tools and instruments designed like celestial spectacles, corrective optics crafted with extraordinary care. When they reached the telescope, they stepped into the silent vacuum to begin their work. Floating gently beside Hubble, they replaced components, tightened fixtures, and installed the new corrective system. It was like performing surgery in slow motion, in a place with no sound and no weight. Every movement was deliberate, guided by training and trust. When the repair was complete and Hubble opened its eyes once more, the universe blossomed into clarity. Stars sharpened, nebulae glowed, and distant galaxies revealed their ancient shapes. The mission became one of NASA's most tender triumphs, a gentle act that saved a dream. Fact 39. Shuttle missions that built the ISS. As the shuttle era continued, its mission shifted toward collaboration and construction. One of its most graceful roles was helping to assemble the International Space Station, a home for science slowly stitched together piece by piece in Earth's quiet orbit. Each module was carried in the shuttle's vast cargo bay, then lifted into place by robotic arms guided by astronauts. Spacewalkers drifted along the growing structure like careful builders, fastening beams and panels while Earth glowed softly beneath their boots. Through these missions, the ISS took shape, not in a rush, but through steady, patient work. The shuttle became a bridge between nations and between Earth and space, helping create a sanctuary where humanity could live and dream among the stars. Fact 40. The shuttle's graceful farewell. After 3 decades of gentle service, the space shuttle prepared for its final descent into history. Its last missions were filled not with urgency, but with a quiet sense of gratitude, a recognition that this reusable ship had carried satellites, telescopes, laboratories, and countless dreams into the sky. When the final landing came, the shuttle glided to the runway one last time, touching Earth with the same soft confidence it had shown for years. Crowds watched in silence, knowing they were witnessing the close of a chapter that had shaped generations. The craft rolled to a stop beneath the warm sunlight, its tiles weathered from journeys through fire and stars. The farewell was gentle, honoring a vessel that turned spaceflight into something almost familiar, a place humans could return to again and again, like visiting a quiet home above the clouds. Fact 41. Hubble's quiet revival. With its vision restored, the Hubble Space Telescope entered a new era of breathtaking clarity. It drifted high above Earth, floating through sunlight and shadow every 90 minutes, its instruments humming softly as they captured scenes from the distant universe. The images it sent back were not just scientific data. They were paintings of reality, brushed in colors of starlight and cosmic dust. Galaxies spiraled with delicate grace. Nebulae glowed like drifting clouds, and star clusters sparkled against the infinite black. Hubble's revival became a symbol of resilience, showing that even in the vastness of space, repairs born of patience and human hands could help a distant instrument shine again. Its quiet gaze continues to offer comfort and wonder, like a lantern hung in the darkness. Fact 42. A telescope paints the universe. As Hubble explored the cosmos, NASA realized that telescopes could be artists as much as scientific tools. The images they produced revealed structures we had never seen: towering pillars of gas, swirling storms on distant planets, and galaxies dancing in slow motion across billions of years. Astronomers stitched these images together like quilts, each panel revealing a new piece of the cosmic story. And as people looked at these pictures from around the world, many found a strange, soothing peace in them, a reminder that the universe, vast as it is, holds patterns of beauty woven through every corner. Hubble didn't just study the skies, it painted them, one glowing frame at a time, inviting us to drift into the gentle depths of creation. Fact 43. The Chandra Observatory listens to X-rays. While Hubble revealed the universe in visible light, NASA's Chandra X-ray Observatory listened to a different, quieter language, the faint whisper of high-energy X-rays drifting through space. Launched in 1999, Chandra slipped into orbit far above Earth's atmosphere, where these delicate signals could reach it without interference. Through its sensitive mirrors, Chandra observed violent but distant events: stars collapsing, black holes humming at the centers of galaxies, and clouds of superheated gas glowing softly in the dark. Yet even these powerful cosmic scenes appeared gentle through Chandra's patient eyes, transformed into images of shimmering blues and purples. By listening to the universe's hidden frequencies, Chandra revealed a cosmic world of quiet storms, forces too distant to frighten, yet beautiful in their drifting light. Fact 44. Spitzer's infrared glow. NASA's Spitzer Space Telescope explored the universe in infrared light, the warm glow that objects emit even when they seem dark to human eyes. Launched into a deep trailing orbit behind Earth, Spitzer drifted through cold space like a silent ember, its instruments chilled to near absolute zero, so it could sense the faintest warmth from distant worlds. Infrared light revealed gentle mysteries: newborn stars wrapped in dusty nurseries, planets circling faraway suns, and galaxies cloaked in veils of cosmic dust. Spitzer's images often appeared soft and luminous, highlighting curves and clouds hidden from visible telescopes. Through this quiet glow, Spitzer helped NASA trace the secret warmth of the universe, showing that even in the coldest corners, light continues to drift and whisper across the ages. Fact 45. Kepler searches for hidden worlds. When the Kepler Space Telescope opened its eyes, it began a mission both simple and profound: to watch thousands of distant stars for tiny dips in brightness that might signal an orbiting planet. These dips were so subtle, often less than 1%, yet Kepler detected them with the calm precision of a patient observer. For years, the telescope stared at the same region of the sky, gathering gentle streams of data. In that quiet persistence, it found evidence of worlds unlike anything imagined: hot Jupiters hugging their stars, Earth-sized planets in temperate zones, and systems filled with multiple worlds drifting in peaceful harmony. Kepler revealed that planets are not rare treasures, but common companions of starlight, countless quiet homes scattered across the galaxy, each waiting softly in the dark. Fact 46. Tess and the Hunt for Gentle Shadows. After Kepler's quiet years of watching a single patch of sky, NASA launched TESS, the Transiting Exoplanet Survey satellite, to search for new worlds across almost the entire heavens. Instead of staring at one region, TESS moved its gaze like a careful painter, surveying the sky sector by sector. It looked for the same delicate sign Kepler did: tiny shadows cast when planets drifted across their stars. These shadows were so faint that only the most patient instruments could notice them. Yet TESS observed them with soft precision, finding thousands of candidate worlds in gentle rhythms of starlight. Many were small and rocky, others large and gaseous, all drifting peacefully in their cosmic orbits. Through this quiet search, TESS expanded our understanding of the galaxy, reminding us that countless worlds may glow softly in the dark, waiting to be discovered. Fact 47. JWST unfolds in silence. The James Webb Space Telescope began its life in space with a moment of profound stillness. After launch, it drifted outward to a distant orbit, carrying mirrors folded like the petals of a golden flower. Over the course of days, those mirrors slowly unfurled in silence, clicking gently into place until the telescope reached its full, shimmering form. JWST's instruments were designed to sense the faintest infrared light, warmth from the earliest stars, galaxies forming in ancient darkness, and subtle signals from planets circling distant suns. Its view stretched farther back in time than any telescope before it, revealing cosmic dawns hidden for billions of years. The unfolding of JWST was a quiet marvel, a delicate choreography that allowed humanity to see the universe as it once was, bathed in the first soft glow of creation. Fact 48. NASA's fleet of skywatchers. Beyond its famous telescopes, NASA maintains a graceful fleet of observatories, each one tuned to a different wavelength of light. Some study gamma rays, the universe's most energetic whispers. Others explore ultraviolet light, mapping the hot atmospheres of stars. Still more drift through Earth orbit, observing cosmic microwave patterns left over from the universe's earliest moments. Together, these satellites create a celestial symphony, a gentle chorus of instruments revealing layers of the cosmos that no single telescope could uncover alone. Scientists weave their data into colorful portraits of galaxies, nebulas, and star clusters, combining perspectives like threads in a tapestry. NASA's skywatchers remind us that understanding the universe is a shared effort, a collection of quiet voices working together across the dark. Fact 49. The beauty of ultraviolet eyes. While many telescopes observe the universe in visible or infrared light, NASA also explores the sky through ultraviolet eyes, instruments that can see the soft glow of stars burning hotter than our sun. These wavelengths never reach Earth's surface, absorbed by our protective atmosphere, so only satellites drifting above the clouds can witness them. Ultraviolet telescopes reveal shimmering details of galaxies, star nurseries, and luminous clouds of gas shaped by ancient explosions. They show where young stars are forming, their energy painting bright strokes across the canvas of space. Through this delicate light, NASA captures a hidden beauty, a world where colors we cannot see still glow with meaning, whispering stories of creation that unfold in soft, radiant patterns. Fact 50. Mapping the cosmic web. Beyond individual stars and galaxies lies something even grander: the cosmic web, a vast network of filaments stretching across billions of light years. NASA's observatories help map this structure by watching how galaxies cluster, how gravity shapes the flow of matter, and how faint wisps of gas connect distant regions of space. Though invisible to ordinary sight, the cosmic web forms the gentle framework of the universe, a quiet scaffolding upon which galaxies grow like sparkling clusters of dew. Through careful measurements of light, motion, and temperature, NASA traces these filaments, revealing their graceful arcs and delicate intersections. Studying the cosmic web reminds us that the universe is interconnected, woven together with threads of gravity and time, stretching softly through the dark. Fact 51. The first Mars. Flybys. Long before rovers rolled across the red sands, NASA sent small, determined spacecraft to Mars to glimpse its mysterious surface up close. Mariner 4, one of the earliest missions, approached the planet like a shy traveler, sending back the first close-up images of another world. The pictures were grainy and simple, yet filled with quiet wonder, proof that Mars was not just a distant point of light, but a place with deserts, craters, and ancient terrain. These early flybys drifted past the planet gently, taking measurements of its atmosphere, its magnetic field, and its weather. Each bit of data was a whisper from a nearby world, hinting at stories still waiting to be uncovered. The first Mars flybys planted the seeds for decades of exploration, opening the door to the red planet's soft, dusty mysteries. Fact 52. Viking touches down gently. In 1976, NASA's Viking missions made history by becoming the first spacecraft to softly touch down on the surface of Mars. After drifting through the thin Martian atmosphere, with parachutes unfurling like quiet blossoms, the landers descended on gentle bursts of thrusters until their legs met the ancient soil. Once settled, Viking began to study the red planet with patient curiosity. It scooped samples of dusty regolith, listened to the desert winds, and searched for faint signs of chemistry that might hint at life. Its cameras revealed a serene landscape, rocky plains stretching toward pale horizons beneath a butterscotch sky. The Viking landings brought Mars closer to humanity, allowing us to see its stillness, its loneliness, and its quiet, enduring beauty. Fact 53. Mars Pathfinder and its tiny explorer. In 1997, NASA returned to the Martian surface with a new kind of mission, Mars Pathfinder and its small rover, Sojourner. Compared to the rovers that would come later, Sojourner was small, no larger than a microwave, but its gentle exploration captured hearts around the world. It rolled across the rocky terrain with patient curiosity, pausing to examine stones, dunes, and soil. Each movement was deliberate and slow, guided by commands that traveled millions of miles through the silent dark. The rover's images showed a landscape both foreign and familiar: distant hills under a peach-colored sky, smooth rocks polished by ancient winds. Pathfinder proved that small explorers could reveal large truths, paving the way for future rovers to continue the soft, steady march across Mars. Fact 54. The Spirit rover awakens. In 2004, the Spirit rover touched down on Mars with a gentle bounce, wrapped in protective airbags that cushioned its landing like a soft cradle. Once the airbags deflated and the rover unfolded, Spirit opened its eyes to a world of rusty sands, scattered stones, and endless horizons. Over the days and months that followed, Spirit became a quiet wanderer. It drove slowly across the Gusev crater, examining rocks shaped by ancient water, dust storms, and time. Each sunrise bathed the rover in pale light, warming its solar panels and giving it strength for another day of exploration. Spirit's journey revealed hints of Mars's watery past and demonstrated the resilience of a tiny machine exploring a vast, silent world. Fact 55. Opportunity's endless journey. Opportunity, Spirit's twin rover, landed on Mars in 2004 with a gentle bounce and a quiet promise to explore for at least 90 days. Instead, it wandered the Martian plains for nearly 15 years, becoming one of NASA's most enduring explorers. Its wheels traced delicate paths across the dusty surface, revealing clues about ancient lakes and minerals shaped by long-vanished water. Opportunity traveled farther than any rover before it, rolling over hills, entering craters, and watching countless Martian sunsets fade into soft amber light. With each sunrise, it gathered its strength, letting thin rays warm its panels before beginning another gentle trek. Its mission became a story of endurance and quiet dedication, a tiny traveler exploring a vast, silent world with unwavering patience. Fact 56. Curiosity's sky crane descent. When NASA prepared to land the Curiosity rover on Mars, engineers designed a method unlike anything ever attempted, the sky crane. As Curiosity approached the surface, a hovering descent stage used rockets to slow the fall, suspending the rover beneath it on soft nylon cables. In the final moments, the sky crane lowered Curiosity gently onto the ground, then released the cables and drifted away to crash safely at a distance. The maneuver was delicate, almost graceful, a quiet choreography performed in thin Martian air. When Curiosity touched the surface, it opened its instruments like petals, ready to study the ancient geology of Gale Crater. Its landing became one of NASA's most poetic triumphs, a soft delivery of a new explorer into a timeless landscape. Fact 57. Perseverance listens for ancient clues. In 2021, NASA's Perseverance rover arrived on Mars with a mission shaped by wonder to search for signs of ancient microbial life. It touched down in Jezero Crater, a place where rivers once flowed and a lake once shimmered beneath a younger sun. The rover carried sensitive instruments designed to listen to the planet's quiet geological stories. The patterns in rocks, the grains of sediment, the textures shaped by water long gone. Perseverance also collected samples meant to one day return to Earth, tiny pieces of Mars preserved in sealed tubes as if saving memories. Each day, it rolled slowly across the crater floor, its cameras capturing soft panoramas of distant ridges and dusty plains. Through Perseverance, NASA continued its patient search for the echoes of ancient life, listening gently to the whispers written in Martian stone. Fact 58. Ingenuity's whispering rotors. Nestled beneath the Perseverance rover was a small, delicate companion, the Ingenuity helicopter. Unlike anything ever flown on another world, it carried rotors designed to spin in Mars's thin, quiet air. When Ingenuity lifted off for the first time, it rose like a gentle breath, a whisper of motion against a vast and silent desert. Its tiny shadow drifted across the dusty ground as it hovered, testing the limits of flight where the atmosphere is barely a breeze. Each hop, each turn, each short journey was a soft declaration that powered flight beyond Earth was possible. Ingenuity became a symbol of Curiosity's playful side, proving that even in a distant ancient world, something small and light could dance upon the air. Fact 59. The search for watered memories. Water leaves quiet traces, and on Mars, NASA has spent decades searching for those subtle signs. Orbiters map ancient riverbeds that meander through craters. Rovers examine minerals that could only form in the presence of gentle waves or trickling streams. From orbit and surface alike, Mars reveals the faint memories of its watery past. These clues suggest that long ago, Mars may have had lakes, deltas, and perhaps entire oceans shimmering under a softer sky. The evidence hides in layered rocks, in rounded pebbles, and in sediments shaped by flowing currents. NASA studies each of these features with patient wonder, hoping to understand why the water vanished and what stories it left behind. The search continues quietly, like listening for an echo from a distant time when Mars was warmer and alive with rivers. Fact 60. Preparing for human footsteps. As NASA learns more about Mars, the dream of sending humans there moves from imagination toward gentle planning. Engineers study habitats that could shelter explorers from the planet's cold nights. Scientists examine soil to understand how it might support life or future crops. Teams test suits, tools, and technologies designed to help humans walk safely on Martian ground. Simulations on Earth mimic the dust, the gravity, and the long isolation that astronauts will one day face. Each study, each experiment, each careful design brings the vision closer, a moment when human footsteps press softly into Martian dust for the first time. Preparing for this journey requires patience and hope, the kind that grows slowly, like a sunrise spreading light across a quiet horizon. Fact 61. Pioneer's first faraway steps. Long before humans dreamed of visiting the outer planets, NASA sent the Pioneer spacecraft to explore the spaces beyond Mars. These small, brave probes drifted outward like paper boats launched onto a cosmic sea, carried by sunlight and momentum into the cool, dim distance of the solar system. Pioneer 10 became the first human-made object to travel beyond the orbit of Jupiter, watching the giant planet grow from a faint dot into a swirling world of storms and clouds. As it passed, its instruments listened carefully, collecting whispers of radiation, magnetism, and solar wind. When Pioneer continued past the outer planets and into the vast frontier beyond, it carried with it a simple plaque, a quiet greeting from Earth to whatever might one day find it, drifting eternally through the starlit dark. Fact 62. Voyager's Golden Greeting. After the Pioneer missions, NASA launched the twin Voyager spacecraft, two gentle travelers destined for the far reaches of the solar system. Each carried a golden record, a shimmering disk engraved with sounds of Earth, birdsong, greetings in many languages, rainfall, and distant music. It was a peaceful offering, a time capsule of humanity's quieter moments. Voyager 1 and Voyager 2 journeyed past the giant planets, sending back breathtaking images of swirling storms, icy moons, and delicate ring systems. They drifted onward with patience, powered by the faint warmth of their radioisotope generators and guided by the soft tug of gravity. Their golden records remain among the most tender artifacts humanity has ever sent into space, small, glowing reminders that even in the vastness, we seek connection. Fact 63. The Grand Tour of the Outer Worlds. The Voyagers traveled along a rare planetary alignment that occurs only once every 176 years, allowing them to visit multiple outer planets in a single journey. This grand tour became one of NASA's most graceful achievements, a slow dance through Jupiter, Saturn, Uranus, and Neptune, guided by celestial timing and careful planning. As each spacecraft approached a new world, the planets revealed themselves like chapters in a cosmic story. Jupiter's swirling storms, Saturn's drifting rings, Uranus's pale blue calm, Neptune's deep sapphire winds. The Voyagers captured it all in serene images, showing humanity places it had only imagined. Even now, as they drift through interstellar space, the Voyagers continue their quiet voyage, carrying humanity's curiosity farther than any other machine ever has. Fact 64. Jupiter's deep cloud belts. When NASA's spacecraft first approached Jupiter, the giant planet revealed itself as a world of swirling colors and endless storms. Its cloud belts, painted in creams, browns, and soft reds, wrapped around the planet like slow-moving rivers of gas. These bands flow in opposite directions, creating gentle yet powerful boundaries that shape the planet's weather patterns. Beneath those clouds lies a world without a solid surface. Only deeper layers of hydrogen and helium, compressed into exotic states by Jupiter's immense gravity. Lightning flashes silently within its storms, illuminating hidden depths for brief, delicate moments. Studying Jupiter's cloud belts teaches NASA about the complex dance of atmospheric forces, showing how even the largest storms can move with a rhythm as graceful as drifting tides. Fact 65. Saturn's ringed silence. Saturn, with its breathtaking rings, stands as one of the solar system's most peaceful wonders. When NASA's spacecraft flew close, the rings appeared not as solid structures, but as countless icy particles, some no larger than grains of sand, others as wide as mountains, all gently orbiting in thin, shimmering bands. From a distance, the rings look smooth and tranquil, but up close, they reveal a quiet choreography shaped by gravity, moonlets, and cosmic time. Light scatters through the icy debris, creating soft glows and delicate shadows that drift across Saturn's golden atmosphere. The planet itself rotates with serene steadiness, wrapped in hazy clouds tinted in pale yellows. In studying Saturn, NASA uncovered a world where silence and beauty coexist in perfect harmony, far from the noise of Earth. Fact 66. Uranus, the sideways planet. Uranus drifts through the outer solar system with a calm uniqueness. It rotates on its side, as though gently tipped by an ancient cosmic hand. This tilt gives the planet unusual seasons that last decades, with one pole bathed in constant sunlight, while the other rests in quiet darkness. NASA's Voyager 2 spacecraft was the only mission to visit Uranus up close. As it passed, it captured a world tinted in soft turquoise, its serene color shaped by methane high in the atmosphere. Though the planet seemed simple at first glance, Voyager revealed faint rings and a family of moons, each with its own quiet story. Uranus reminded NASA that even the most distant worlds can hold gentle surprises, waiting patiently for curious eyes to discover them. Fact 67. Neptune's sapphire winds. Farther than any other major planet, Neptune circles the Sun in a quiet, distant orbit. When NASA's Voyager 2 flew past in 1989, it revealed a world wrapped in deep sapphire hues. A planet whose rich blue color comes from methane absorbing red light, leaving only cool tones drifting through its atmosphere. But beneath that calm appearance lies the fastest wind system in the solar system. Storms swirl at incredible speeds, yet from afar, they move with a gentle elegance, like soft brushstrokes on a midnight canvas. Voyager captured images of dark spots, vast tempests drifting across the planet's face, each moving with a strangely soothing rhythm. Neptune's winds remind us that even the most powerful forces in space can appear delicate from a peaceful distance, swirling soundlessly in the endless cold. Fact 68. Cassini's dance through Saturn. NASA's Cassini spacecraft spent more than a decade orbiting Saturn, performing a graceful ballet through the planet's rings, moons, and swirling clouds. It glided between icy particles and moonlit shadows, sending back images that felt almost like dreams. With every orbit, Cassini revealed something new, a ripple in the rings, a storm blooming on the surface, a moon casting a soft shadow across the golden atmosphere. Cassini's path was carefully planned, its thrusters whispering gentle corrections as it drifted among Saturn's wonders. Often, it skimmed past moons like Enceladus and Titan, tasting their environments with delicate instruments that captured faint chemical clues. Its long mission became a study in elegance and patience, showing how a spacecraft could move like a dancer among celestial giants, collecting stories written in ice and light. Fact 69. The Huygens probe falls to Titan. As part of the Cassini mission, the Huygens probe detached and drifted toward Titan, Saturn's largest moon. Wrapped in protective layers, it descended slowly through Titan's thick, hazy atmosphere. Winds carried it gently downward, and sensors listened to the quiet changes in pressure and temperature as it approached the surface. For more than 2 hours, Huygens floated like a falling leaf, passing through layers of orange mist, before finally touching down on a landscape of rounded pebbles and frozen terrain. The world around it was dim and serene, a place where methane falls as rain and rivers carve soft pathways through ancient ice. Huygens gave humanity its first close glimpse of Titan's peaceful, alien beauty, revealing a world that felt both familiar and dreamlike, resting in the chill shadow of Saturn's rings. Fact 70. New Horizons and the Pluto Dawn. For decades, Pluto lingered at the edge of our solar system like a distant whisper, too small, too far, too cold to reveal its secrets easily. Then NASA sent New Horizons, a small, determined spacecraft that quietly crossed 3 billion miles of space to meet this icy world. For nearly 10 years, it sailed through the deep, dark quiet, guided only by faint sunlight and its steady purpose. When New Horizons finally arrived, Pluto blossomed into view. A world patterned with heart-shaped plains, softly carved mountains of frozen nitrogen, and mysterious patches of icy haze drifting through its thin atmosphere. The images arrived like postcards from the outer twilight, each one gentle and breathtaking. New Horizons showed humanity that even the most remote corners of the solar system hold beauty waiting patiently to be seen. Fact 71. NASA turns its eyes to Earth after decades of looking outward. NASA also turned its gaze inward, toward the blue planet we call home. From orbit, Earth appeared not as a world of borders and divisions, but as a single, glowing sphere wrapped in clouds and ocean mist. Satellites drifting gently above the atmosphere captured patterns of weather, currents, and climate, revealing the planet's quiet rhythms. These Earth-observing missions watched forests breathe through the seasons, deserts shift with the winds, and ice sheets expand and retreat like slow-moving tides. NASA studied storms swirling over oceans and traced the paths of rivers winding through continents. By looking at Earth from afar, NASA offered a new perspective, one of unity, fragility, and calm, reminding us of the delicate beauty of the world beneath our feet. Fact 72. The quiet work of weather satellites. High above the clouds, weather satellites glide in serene orbits, watching Earth with steady patience. Their sensors measure temperature, humidity, and the movement of storms, gathering gentle streams of data that help meteorologists understand the atmosphere's shifting moods. Some satellites hold their position over a single region, keeping constant watch, while others drift around the planet, capturing snapshots of changing clouds and storm systems. From space, even hurricanes, powerful and immense, appear like swirling spirals of soft white, moving with slow, hypnotic grace across the oceans. NASA's weather satellites help protect communities, guide predictions, and reveal the subtle dance of Earth's atmosphere. Their continuous vigil reminds us that science can bring comfort, offering knowledge that helps us navigate both calm and storm. Fact 73. Studying ocean currents from above. Far below the quiet paths of Earth-orbiting satellites, the oceans move with a slow, ancient rhythm. NASA studies these currents from space, watching how they swirl like vast, shimmering rivers beneath the surface. Using delicate sensors, satellites measure temperature, color, and subtle shifts in sea height, clues that reveal where warm and cold waters drift. From orbit, the Gulf Stream glows like a ribbon of warmth weaving across the Atlantic, while currents in the Pacific form spiraling eddies that dance gently for months at a time. These movements shape weather, nurture marine life, and carry heat around the globe like a hidden heartbeat. NASA's ocean studies remind us that even the vast seas have patterns as calm and graceful as a lullaby whispered across the planet. Fact 74. The breathing patterns of forests. Forests may seem still from the ground, but NASA's satellites reveal that they breathe, inhaling carbon dioxide and exhaling oxygen through the seasons. From space, these vast green expanses appear to pulse softly as leaves grow, flourish, and eventually fall. Each cycle forms part of Earth's gentle rhythm, one that has continued quietly for millions of years. By tracing the subtle colors of vegetation, satellites show where forests thrive and where they struggle. They watch treetops brighten in spring, deepen in summer, and slowly fade toward autumn. This aerial perspective helps scientists understand climate, biodiversity, and the health of ecosystems. Through these observations, NASA listens to the planet's lungs, hearing the steady, peaceful breath of forests that sustain life across the globe. Fact 75. Tracking Earth's changing ice. In the coldest corners of Earth, glaciers and ice sheets move with a grace too slow for human eyes to notice. But from space, NASA's satellites can observe their gentle shifts. The thinning of frozen layers, the drifting of icebergs, and the transformation of polar regions through the decades. Using laser altimeters and radar systems, satellites glide over Antarctica and Greenland, measuring subtle changes in height and shape. These observations reveal how ice responds to warming oceans, shifting temperatures, and the quiet touch of sunlight. Though the ice may seem unchanging, NASA shows us that it is alive with motion, creeping forward, retreating, cracking softly under stress. Tracking these changes helps humanity care for a world where every frozen whisper matters. Fact 76. The story. Written in clouds. From space, clouds tell quiet stories. NASA's satellites observe them like drifting pages, each formation offering clues about moisture, temperature, and the delicate balance of Earth's atmosphere. Wispy cirrus clouds stretch like silver threads across the sky, while billowing cumulus towers rise softly over warm landscapes. Seen from orbit, storms look almost peaceful, swirling spirals of white cotton turning slowly across blue oceans. Satellites track their shapes, their shadows, and the subtle ways they grow or fade. Even tiny cloud patterns, unnoticed from the ground, reveal how air moves through invisible pathways above us. By watching clouds from this calm vantage point, NASA learns how rain forms, how storms evolve, and how the atmosphere breathes. Each cloud becomes a gentle brushstroke in the portrait of our living planet. Fact 77. Measuring Earth's subtle movements. Though Earth feels solid beneath our feet, the planet is always shifting, plates drifting, mountains rising, and valleys settling. NASA studies these quiet movements using satellites that measure tiny changes in gravity, shape, and elevation. From hundreds of miles above, they detect shifts as small as a few millimeters, showing how Earth changes slowly over time. Missions like GRACE track how water moves beneath the surface, revealing the gentle ebb and flow of aquifers. Others map the movement of tectonic plates, tracing the slow wanderings that shape continents. Even volcanic swelling and sinking can be measured with serene precision. By observing these subtle motions, NASA helps scientists understand our planet's inner rhythms, the deep, patient forces that sculpt the world as softly as time itself. Fact 78. Satellites that guard our climate. NASA operates satellites that watch over Earth's climate like calm, vigilant guardians. These instruments measure atmospheric gases, solar energy, surface temperatures, and ocean heat content, offering a steady stream of information that helps scientists understand long-term changes. Each satellite contributes a unique perspective. Some track the faint signature of greenhouse gases, others record how much sunlight Earth reflects, and still others monitor changes in sea level or soil moisture. Together, they form a gentle, continuous watch, a quiet vigilance that spans decades. By guarding our climate with such care, NASA provides the knowledge humanity needs to protect and cherish the planet. These satellites remind us that understanding leads to action, and that even the softest data can guide us toward wiser choices. Fact 79. Mapping wildfires. From orbit high above the Earth, NASA's satellites quietly watch for the faint signatures of wildfires, gentle pulses of heat, thin streams of smoke, and the subtle glow of flames spreading across forests and grasslands. From orbit, fires look almost delicate, their smoke drifting like pale veils across the landscape. Using infrared sensors, satellites detect fires even through clouds, helping firefighters understand where flames are moving and how quickly they grow. They study burn patterns, track hotspots, and follow the winds that carry smoke across continents. What seems chaotic on the ground becomes a graceful, swirling pattern from above. By mapping wildfires, NASA offers knowledge that helps protect communities and ecosystems. In the calm clarity of orbit, the story of fire becomes easier to understand and easier to prepare for. Fact 80. Listening to the planet's pulse. Earth has a rhythm all its own, and NASA listens to it through a variety of quiet, steady instruments. Some satellites measure the planet's gravitational pull, watching as it changes with melting ice or shifting groundwater. Others record tiny variations in surface temperature, revealing how seasons breathe warmth across continents. Even the oceans send signals: subtle rises and falls in sea level, slow circulations of heat, and faint pulses from underwater activity. NASA weaves these gentle clues into a picture of Earth's health, much like listening to a heartbeat reveals the well-being of a living creature. By hearing this planetary pulse, scientists understand how Earth responds to natural cycles and human influence. It is a soft reminder that our world is alive with motion and that every movement carries meaning. Fact 81. The quiet roots in aeronautics. Before NASA became known for exploring distant planets and drifting space telescopes, its earliest work blossomed in aeronautics, the science of flight here on Earth. In wind tunnels filled with gentle airflow, researchers studied how wings lift, how air flows over surfaces, and how engines could become safer and more efficient. These tests were calm and methodical, involving delicate instruments that measured tiny shifts in pressure and turbulence. Engineers crafted models of future aircraft, refining shapes that would glide more smoothly through the sky. Each experiment, though simple on the surface, helped build the foundation for modern aviation. NASA's aeronautics roots remind us that exploration begins close to home, with a single wing in a quiet tunnel, teaching us how to move gracefully through the air. Fact 82. Testing the wings of tomorrow. NASA's aeronautics teams spend countless quiet hours studying the wings of future aircraft, shapes designed to glide more gently, fly more efficiently, and leave softer footprints on the skies above. In long, echoing wind tunnels, smooth streams of air flow steadily over the wings, revealing where currents hug the surface and where they drift away. Engineers adjust angles by tiny degrees, listening to sensors that whisper how the air responds. They imagine planes that use less fuel, make less noise, and slip through the atmosphere with the grace of a bird soaring on warm currents. Each experiment brings tomorrow's flight a little closer, showing how thoughtful design can create aircraft that move through the sky with calm, effortless elegance. Fact 83. The X-planes break barriers. NASA's X-planes are quiet pioneers, experimental aircraft built not for passengers, but for discovery. Over the decades, these sleek machines have tested new shapes, new engines, and new materials, helping aviation push gently beyond its limits. Some broke speed records, touching the edge of supersonic flight. Others explored unusual wing shapes or new ways to control airflow. Though their missions often sound bold, the work is serene and deliberate. Pilots guide the aircraft with steady hands, while engineers monitor each moment from the ground, gathering data that will shape the future of aviation. The X-planes show that progress doesn't always roar. Sometimes it arrives in soft increments, carried by the quiet determination to fly farther, higher, and more efficiently than ever before. Fact 84. The sound of sonic booms. Softened. For many years, breaking the sound barrier created a loud, startling boom, a sharp echo that rippled across towns and landscapes. NASA has long dreamed of softening that sound, turning it from a jarring crack into something closer to a gentle thump, barely heard at all. To achieve this, engineers study how shock waves form around fast-moving aircraft. They adjust nose shapes, wing angles, and fuselage curves, crafting designs that reshape the air with subtle precision. In testing flights, microphones scattered across the ground listen for the softened signature, tracing how the modified shock waves spread. If successful, future aircraft could travel faster than sound with a whisper instead of a roar, opening the door to quiet, graceful, supersonic travel that moves like a swift breeze across the sky. Fact 85. Electric aircraft dreams. As NASA looks toward the future of flight, it imagines aircraft that hum softly through the sky, powered not by roaring engines, but by quiet electric propulsion. These experimental designs aim to move as gently as gliders, leaving behind cleaner air and calmer skies. In laboratories and test facilities, engineers study lightweight batteries, whispering motors, and wings embedded with tiny propellers. Each component is crafted to reduce noise and improve efficiency, creating a delicate balance between technology and tranquility. These electric aircraft could one day transform the sky above crowded cities, offering smooth, low-noise travel. NASA's quiet dream is a future where flight becomes more harmonious, where the atmosphere holds only the soft whir of electric wings drifting through the air. Fact 86. Greener aviation takes flight. NASA's aeronautics program is devoted not only to innovation, but to care, finding ways to make aviation gentler on the planet. Researchers study fuel efficiency, sustainable materials, and new engine designs that emit less pollution. Even tiny improvements, when applied across thousands of aircraft, create meaningful changes for Earth's atmosphere. In wind tunnels, models shaped like future airplanes are tested for ways to reduce drag. In hangars, hybrid engines are examined for their quiet power. On computer screens, simulations map the airflow of redesigned wings and predict how they'll glide through real skies. This steady work brings NASA closer to a greener future, one where the joy of flight coexists peacefully with the health of our world, carried forward by thoughtful engineering and gentle intention. Fact 87. Studying the language of airflow. Air may seem invisible, but it speaks a complex language, swirling, curling, lifting, and guiding everything that moves through it. NASA studies this language with patient curiosity, using smoke trails, sensors, and computer models to reveal hidden patterns. In wind tunnels, graceful streams of air flow over wings as delicate sensors trace their behavior. Scientists watch for tiny eddies, smooth laminar flows, and sudden shifts that could affect a plane's stability. These observations help engineers design aircraft that fly more smoothly, with wings that work in harmony with the air around them. By listening to the silent conversation between air and flight, NASA learns how to create aircraft that move with greater ease, crafting designs that turn turbulence into calm and chaos into elegance. Fact 88. The art of safer flight. Safety in aviation is a quiet art, a blend of careful study, thoughtful design, and gentle anticipation of what might happen in the skies. NASA dedicates countless hours to this work, developing systems that help aircraft avoid hazards, withstand turbulent weather, and communicate more clearly with pilots and other planes. In simulators that glow softly with instrument lights, pilots practice rare or difficult situations so they can respond calmly if they ever occur in real flight. Engineers refine sensors that can detect icing on wings, wind patterns near runways, or unseen obstacles in cloudy skies. These technologies act like guardians, watching over every stage of flight. NASA's safety research ensures that each journey through the air becomes a little more predictable, a little more peaceful, allowing travelers to rest easily, cradled in the steady hum of a well-protected aircraft. Fact 89. Quiet jet designs. Jets are powerful, but NASA dreams of aircraft that slice through the sky with far less noise. A gentle whisper instead of a thunderous roar. Noise-reducing designs begin with reshaping the engines, placing them in positions where their sound is softened by wings or fuselage. Other ideas involve changing landing gear shapes or adjusting how air flows around the plane to reduce rumbling vibrations. In open fields, dotted with microphones, engineers listen to every detail. The tone of an engine spool-up, the hush of air over new wing curves, the softened rush of exhaust passing through redesigned nozzles. Even the wingtips are sculpted to tame small vortices that can add faint, lingering noise. These innovations promise a future where planes glide more quietly above neighborhoods, a sky filled with movement, but touched with newfound calm. Fact 90. The future of airborne innovation. NASA's vision for the future of flight stretches far beyond today's runways. Engineers imagine aircraft that take off vertically like gentle elevators, drones that deliver supplies with the grace of drifting leaves, and high-altitude platforms that float for months, observing weather and climate from the quiet edge of space. Some designs look like sleek birds with long, slender wings. Others seem almost dreamlike, blended shapes without clear distinctions between wing and body, crafted to slip through the air with remarkable efficiency. In quiet labs and virtual simulations, these futuristic craft begin their lives as simple ideas, slowly refined into concepts that might one day reshape the way we travel. NASA's airborne innovations remind us that flight is still young, still full of possibility, and still guided by humanity's soft desire to move gently through the sky. Fact 91. Artemis returns to the moon. As decades passed after Apollo, NASA began to dream of the moon once more. Not as a place for a brief visit, but as a destination for long, peaceful stays. This dream became Artemis, a program designed to bring humans back to the lunar surface with new care, new technology, and a gentler rhythm. Artemis aims to land the first woman and the first person of color on the moon, honoring the diverse hands and minds that now shape space exploration. Its spacecraft, Orion, glides through space like a modern lantern, guided by calm precision and protective systems refined over generations. The return to the moon is not just a journey outward, it is a journey forward, carrying humanity's curiosity back to the quiet silver world that once watched our first footsteps. Fact 92. Building a lunar gateway. As part of Artemis, NASA plans to build the Lunar Gateway, a small, serene space station that will orbit the moon like a patient companion. This outpost will serve as a gentle way station for astronauts, a place to rest, conduct research, and prepare for descents to the lunar surface. The gateway will be assembled piece by piece, much like the International Space Station, but on a smaller and quieter scale. Its modules will glide into lunar orbit and connect slowly, forming a hub that drifts above craters, mountains, and the long shadows cast by lunar dawn. From this vantage point, astronauts will watch Earth rise over the moon, glowing softly against the black sky. The gateway will be a bridge, a calm link between worlds, helping humanity learn to live farther from home. Fact 93. Preparing for Martian journeys. Mars has long called to humanity with its rusty landscapes and ancient secrets, and NASA's future plans gently turn towards sending humans to the red planet. Preparing for such a journey requires patience and imagination. Astronauts must learn how to live in deep space for months at a time, how to grow food far from Earth, and how to stay healthy in places where sunlight and gravity are soft and unfamiliar. Simulated habitats on Earth recreate the isolation of Mars, allowing crews to practice routines and discover the rhythms of long-duration missions. Engineers test propulsion systems that could shorten travel time, while scientists study how to extract water from Martian soil. Preparing for Mars is like practicing for a long, quiet voyage across an unknown ocean, one that will lead humanity to its next distant shore. Fact 94. Robot scouts for distant moons. Before humans ever set foot on distant worlds, NASA sends robotic scouts, quiet explorers designed to drift, glide, and land in places far too remote for human travel. These robotic missions study icy moons like Europa and Enceladus, where hidden oceans may slosh beneath frozen crusts. Using delicate instruments, they listen for faint tremors, measure chemical signatures, and scan surfaces for clues about what lies below. Some future probes may drift through alien atmospheres or plunge softly into seas of methane on Titan, capturing stories written in the chemistry and tides of strange worlds. Though they travel without heartbeat or breath, These robotic scouts are like humanity's gentle fingertips brushing the unknown, preparing the way for future explorers to one day follow. Fact N95: Missions to Metal Worlds. Among NASA's most intriguing plans is a mission to Psyche, an asteroid believed to be made largely of metal. Unlike rocky or icy worlds, Psyche may be the exposed core of a long-lost protoplanet, offering a rare glimpse into the building blocks of planetary hearts. The spacecraft, also named Psyche, will approach the metallic world slowly, letting its instruments trace the asteroid's surface with patient curiosity. Scientists hope to learn how metal-rich planets form, why Psyche shines with its unusual composition, and what secrets lie hidden in its craters and ridges. Exploring a metal world feels almost like uncovering the quiet skeleton of a planet, a chance to study the ancient bones of our solar system, preserved in silent orbit between Mars and Jupiter. Fact 96: Exploring icy oceans beyond Earth. NASA dreams of visiting worlds that hide oceans beneath their frozen shells, places where warmth from within meets ice from above, creating potential havens for life. Moons like Europa and Enceladus may harbor vast seas, kept liquid by gentle tidal heating from the immense planets they orbit. Future missions aim to glide through the plumes spraying from Enceladus, tasting their chemistry like snowflakes caught on a tongue. Others may orbit Europa, scanning its cracked surface and listening for echoes from the ocean beneath. These efforts bring humanity closer to understanding whether life could exist in the soft darkness of alien seas. Studying these frozen worlds teaches us that warmth and possibility can thrive even in the coldest corners of space, waiting quietly beneath layers of ice. Fact 97: Solar sails, catching sunlight. NASA is exploring a graceful way to move through space using nothing more than sunlight itself. Solar sails are thin, shimmering sheets designed to unfurl like delicate fabric in the vacuum of space. When sunlight touches them, each photon delivers a tiny push, so gentle it feels almost imaginary, yet steady enough to carry a spacecraft across the solar system. There is no roar of engines, no burning fuel, only silence and the endless whisper of light pressing against the sail. Over time, this quiet force builds, allowing a craft to glide farther and faster, much like a sailboat drifting on a calm ocean breeze. Solar sails offer a peaceful form of travel, a voyage powered by starlight, drifting softly through the vast and patient dark. Fact 98: Future telescopes to see beginnings. NASA dreams of telescopes even larger and more sensitive than the ones we have today. Instruments that could gaze deeper into the universe's past, capturing the soft glow of the first stars and galaxies. These future observatories may unfold in space like enormous petals, forming mirrors so wide they could collect the faintest light from the dawn of time. Some proposed designs float far from Earth to escape any interference, resting in quiet orbits, where the only sound is the subtle hum of their instruments. Others might combine multiple spacecraft into one coordinated observatory, working together like gentle eyes scanning the early cosmos. These future telescopes promise glimpses of creation itself, the universe when it was young, shimmering with the first hints of starlight. Fact 99: Dreams of interstellar travel. Even as NASA studies planets, moons, and distant galaxies, it quietly keeps a place in its imagination for something even more ambitious: interstellar travel. This dream involves crossing the vast space between stars, a journey that would take decades or even centuries with current technology. Yet the ideas continue to drift through NASA's halls like soft possibilities. Engineers explore concepts such as nuclear propulsion, giant laser-driven sails, and spacecraft that could one day reach distant star systems. These concepts are early, delicate, and far from realized, but they reflect humanity's gentle longing to know what lies beyond our sun's warm glow. Interstellar travel remains a future whisper, a horizon that calls to us softly, reminding us that curiosity has no boundary. Fact 100: NASA's ever-growing legacy. NASA's story is not a single moment, or mission, or milestone. It is a slow and steady unfolding, like a constellation forming one soft star at a time. From the quiet rooms where early engineers dreamed of touching the sky, to the distant probes now drifting in interstellar space, every step has added a new thread to a vast tapestry of discovery. Its legacy grows gently with each generation. Students inspired by shimmering images of galaxies, scientists tracing patterns in starlight, and explorers preparing to walk again on lunar dust. NASA's work reminds humanity that curiosity is timeless and wonder is endless. Through every rocket launch, every rover's whispering wheel, every telescope opening its golden eye, NASA continues to guide us toward understanding. And as the universe slowly reveals itself, NASA's legacy expands, a calm, steady beacon leading us deeper into the quiet beauty of the cosmos. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. NASA's story is vast, but when told slowly, one quiet fact at a time, it becomes something soothing, a reminder that discovery can be as peaceful as drifting through space. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next sleepy astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.